Hi, I'm Joel Keenan. Thank you for joining me. This is a PowerPoint presentation about magnesium's effect on insulin resistance based on a systematic review of 4 randomized controlled clinical trials that I did for APN 760. That's a micronutrients course at the University of New England, a nutrition master's program with Dr. Marie Boyle. So for this presentation, I'm trying to answer the question for insulin-resistant adults, how effectively does oral magnesium supplementation reduce insulin resistance? By way of background, insulin resistance is prevalent now at 38% of adults in America, and almost half of adults over 65 are insulin resistant. Insulin resistance is often described in the context of metabolic syndrome, for which impaired fasting glucose is one of the 3 or more criteria that make that diagnosis. Over half of U.S. adults over 60 have metabolic syndrome, and there are the criteria there. Insulin resistance is caused ultimately by oxidative stress, in this context by chronic inflammation. And it does that chiefly by reactive oxygen species blocking insulin receptor cell membrane binding of a protein called glucose transporter 4, or GLUT4. That protein is essential to bind to the cell membrane, allowing glucose to get into the cells. Insulin resistance inhibits that process, causing increased insulin production and therefore additional oxidative stress. Magnesium is an essential mineral found in leafy green vegetables, whole grains, and other healthy foods. After potassium, it is our most abundant intracellular cation. It's poorly measured by serum magnesium, which is the way we do measure it, because that's such a small percentage of the total body magnesium. Most of our magnesium is in our bones. Phytates found in legumes impair the absorption of magnesium, and not shown on this slide is that vitamin D3 in therapeutic levels promotes absorption of magnesium. Magnesium plays an important role in glycemic control, mostly by acting on that glucose transporter 4 protein, whose job it is to allow glucose into the cell. That protein moves from the interior of the cell to its membrane, in part with the assistance of magnesium. Here's a diagram showing that. So it's important in that respect, but in many others as well. A review done in 2022, just last year, described very nicely the pleiotropic effects magnesium has in improving or resolving insulin resistance. I won't go through all those here, but you can see just by glancing at this slide that by a variety of mechanisms, magnesium improves insulin and glucose metabolism. So knowing insulin resistance and oxidative stress are so prevalent, and that magnesium in theory could help solve that problem, that prompted my research question. Among adults with insulin resistance who have either impaired fasting glucose or metabolic syndrome or type 2 diabetes, how much do various doses of magnesium help improve insulin resistance as measured by 2 indices, HOMA-IR, which is a function of fasting glucose and fasting insulin levels, or by glycohemoglobin A1C levels, which is measuring really average glucose levels over the prior 90 days. I looked at studies 45 days or more and looked for randomized controlled trials that would compare that intervention to a diet with no supplementation. I used the search terms shown here by MESH and by Boolean method, searching 2 databases, Medline and PubMed Central, and entered those terms and came up with 22 results. Excluded 18 of those based on various criteria I'll discuss shortly, and found 4 randomized controlled trials done in the last 6 years that were appropriate for this systematic review. The inclusion criteria for these studies included adults. They had to be insulin resistant in one form or another, whether or not they were diabetic. I looked for only randomized controlled trials with a placebo group, at least 45 days in duration, and they were English study styles. Studies that were included all inpatient studies, ultimately those over 6 years old, although my initial query included studies over 10 years old. Studies had to have more than 40 participants and less than a 20% dropout rate. And this is a cartoon of the Prisma diagram showing the sequence arriving at those 4 randomized controlled trials. The excluded studies were excluded for a number of reasons. Most of them were excluded because my search query returned articles more than 10 years old. That left about 11, and of those, they were excluded for some of the reasons you see listed here, including multiple supplements, which would introduce a confounding problem. There were a couple of studies with prescription drugs as well as magnesium involved. Some had an excess dropout rate, and one of them had only kidney transplant recipients. So of those 4 randomized trials, the results were basically as follows. In one study of 54 diabetics on hemodialysis, compared to the placebo group, the group receiving 250 milligrams of magnesium showed a 6% relative decline in their HOMA-IR scores and an absolute reduction of their hemoglobin A1C by 0.6%. Just to be clear about that hemoglobin A1C measure, that means had the A1C average been 7.6%, it would have declined to 7%. So that's not a relative risk decline, it's an absolute risk decline. Talari's study of those 54 diabetics had the placebo-controlled control group, and that group showed no significant change in the A1C and HOMA-IR values. And the study was limited by the fact that they were only dialysis-dependent patients, and it was a small sample size. The second of the 4 randomized trials I looked at, done in 2020, looked at 40 insulin-resistant patients and randomized them to oral magnesium for 2 months. Among the intervention group, there also was a 12% relative decline in HOMA-IR scores, but no change in the hemoglobin A1C value. Of note, that study was just 2 months, less than the 3 months you would need to accurately measure a change in glycohemoglobin A1C. Limitations of that study as well were the short duration and a small sample size. There were also other ingredients involved in this because they used a seawater formula to administer the magnesium, and that had other ingredients in it, introducing a confounding risk. The third study, done in 2017, looked at 114 insulin-resistant adults and over a 90-day period, and that too showed a significant decline in the HOMA-IR level of just about 32% and reduced the A1C value by an absolute number of 0.4%. That control study showed no significant change, and it was limited by a small sample size. And finally, the 4th study I looked at 40 diabetic adults, giving them 250 milligrams of oral magnesium over 90 days versus a placebo, and that as well showed a significant drop in the HOMA-IR score of 28% and a noticeable drop of the A1C of 0.36%. That study was limited by its small sample size. The control sample actually increased A1C and HOMA-IR for both values. So if you look at those 4 randomized trials in aggregate and you average their results, what you have is just about 250 insulin-resistant adults who were randomized to between 250 and 365 milligrams a day of magnesium. The other half randomized to placebo. And in that placebo group, there was no significant change in HOMA-IR or hemoglobin A1C, while the intervention group in all 4 studies showed a significant decline in the HOMA-IR, on average, just about 20% reduction. And there was, too, a significant decline in the hemoglobin A1C, even though one of the studies couldn't show that. Again, that was an 8-week study. So from these studies, it's fair to conclude that daily oral magnesium supplement of 250 to 365 milligrams improves insulin resistance in those insulin-resistant adults with clinically significant declines in the HOMA-IR scores. And there's the caveat, as I noted above, about the hemoglobin A1C finding. The evidence grade for these studies was overall grade 1 with strong quality and consistency and clinical impact. The study strengths among these 4 clinical trials included showing that significant relative decline in HOMA-IR values over a really short period of time. This is clinically important because insulin resistance is a major cause not just of diabetes, but of atherosclerosis and its basis in chronic inflammation. So there's a real significant clinical benefit to this supplement. Further, all 4 studies were randomized trials with a placebo arm, making inference about causation more feasible. The studies, as I noted above, were limited by their size and their relatively short duration. One of them, as I noted, used magnesium that had other ingredients, and one limited participants to hemodialysis, limiting generalizability to the adult population in question. That said, these 4 studies invite further research, given their findings, to determine what's the optimal form of magnesium. There are several different kinds: magnesium oxide and carbonate, citrate, and glycinate. And what's the optimal dosing? The dosing ranged in these studies, as you saw. And finally, what population is likeliest to benefit from supplementation? Magnesium might be good for non-insulin resistant people. To that end, it would be useful to show studies of longer duration, include populations that don't have insulin resistance, vary the doses, include plant-based magnesium supplementation, and offer interventions with various forms of magnesium salts. The implications for clinical practice are twofold, I think. They strongly support magnesium supplementation for insulin-resistant adults, and they support a renewed focus on increased consumption of plants that are rich in magnesium. So those were my findings. Thank you so much for watching, and I hope this was helpful.